Hello everybody! Today I'm going to talk about stack. Stack is a built-in data structure. It's based on LIFO principle. LIFO stands for last in, first out. It means the element that put it in a stack last, like this one, is gonna be removed first. You may think about a stack as a pile of plates. So whenever you add plate in a pile, the last you added gonna be the first one to remove. Stack has 5 built-in methods. Those are push, when you add a new element to the stack, pop, when you remove, like get and remove the element from the top of the stack, then pick, when you just get but do not remove the element. The third one is empty. It just checks and returns boolean if stack is empty or not. And search. It determines whether stack exists or whether element exists in stack or not. So let's try to implement stack ourselves. Java already has stack implementation, but on interview you might be asked to do it yourself. So I'm gonna implement 4 methods: push, pop, pick, and isEmpty. Push to add the element on the top, pop to return and remove the element. It will return integer. For example, I have a stack of integers. And pick gonna just return the element but do not remove it from the stack. And isEmpty is gonna return just true or false if stack is empty or not. So I'm gonna use linked list approach for implementation, and for that I need to create an inner class for my stack nodes. I'm gonna create it right here and call it node. And it will have 2 fields. As I say, I'm gonna have stack of integers, just for simplicity. And first one's gonna be my data. And the second one is a pointer to the next node, the element below the top, basically. Right, and I'm gonna create a small constructor here, just to initialize my data. Okay, this data equals data. I made it private because I'm not going to use it elsewhere besides the custom stack class. Okay, so first of all I need another field here for the node, for the top, because it's where I'm going to add and remove my elements. Right, so let's start with the push. Push probably the hardest. To push an element, I need first to create it, right? And I'm gonna push a node. So let's create a node. I'm gonna call it new top because it's new and it's gonna be added on top. Right? That's where we used our constructor. Now I need to update my top reference, right? Not actually top reference, but reference to the next element. What I mean that the new top next is gonna point to the top, to the old top, the element that used to be on top, right? And the top need to be updated as well. The top now equals new top, right? That's why I call it new top. Okay, that's it with push. Let's move to the pop. To pop element, I'm gonna create a temp variable which actually will be the data I'm gonna return. It's a top data. Stack returns the last element, right? And I'm not just return it, I want to remove it. And to remove the last element, I need to update pointers. So the top pointer is gonna point now to top next, right? The one below. And we just return in temp. That's it with pop. Let's move to pick. Pick is even easier than pop. I'm gonna just return top data. I don't need to check pointers here. Well, one thing you need to check with pop and pick is if the stack has data in it. because if stack is empty, you have to throw empty stack exception, right? I'm not gonna do it right now just to keep the code simple, but to do that you just need to check top. If top equals null, then throw that exception. And is empty probably the easiest method left. It just, as I already said, how we check top, it just returns true if top equals to null. That's it.